Our next speaker is Addison Huddy, and he'll be talking to you today about how he can save money.
Yeah.
All right, well, come on up.
Cool. Thanks, everybody. Yeah, claps. Woo! All right. Hi, everyone. Not everyone's got this title. I showed this to a couple people, but we're running less on Kafka costs, right? My prompt is $. Who else's prompt is $? Okay. My name's Addison. I work at Confluent. I used to write software, and I talk about it sometimes on Twitter, but mostly this is my life. I look at how to save both Confluent and our customers money with Kafka. So I work as a product manager today at Confluent, and this is primarily what I do. So today's agenda, and I'm guessing while you all are here, is our goal today is to save money. It's one of my favorite things to do. Like I don't know about you, but I like to save $1 more than spend $1. Like I get more utility out of saving. So anyway, we're gonna have fun doing that. We're gonna save money by looking really closely at Kafka costs, in particular those around storage, compute, networking, and then we'll add some operational bits into it. So, but I know this is it's an intimate group here, and I'm thinking we're like everyone here is looking to save money on Kafka. Like that's top of mind. Like show of hands, who has like an objective in the next like 2 quarters to save infrastructure costs? Yeah? Yeah, good. Yeah, me too. So let's kind of go through this. Okay, the way that we're gonna understand Kafka costs is we're gonna look in particular on two workload types that will help us tease out where the costs of Kafka actually come from. We'll look at a smaller workload that is 20 megabytes per second with a 3x fan out. We'll look at a larger workload that is 100 megs and 300 out with, it's a little bit larger. We're gonna assume we're gonna be using AWS in our analysis. So this doesn't apply to all clouds. We're gonna be running across 3 availability zones. As we look at these workloads, we're gonna have an RF of 3, and we're gonna have 7 days retention. Pretty much a like default Kafka workload. One thing to note, we're gonna ignore a bunch of costs. Like these are kind of be the heavy hitters, but we're gonna be ignoring any load balancers, any NAT gateways, Kubernetes costs of monitoring, and then the overall cost of securing it. These are things that can add on to your bill, and in my experience when examining a lot of Kafka clusters, they add somewhere between 10 to 15% above what the kind of core infrastructure is of the bill. So just something to keep in mind. We're also going to be ignoring kind of any discounts. I'm just going to be using rack rates on AWS as I go through this. Your cloud provider discounts are between you and your cloud provider. So take those into consideration. But the one thing I will say about cloud provider discounts is they are like Costco, right? The more you buy, the bigger the discount, right? The more you commit, the bigger your discount. And I'm a huge fan of Costco. I go there almost weekly, it feels like. But yeah, cloud provider discounts are like Costco. So you need to be thinking about, okay, how can I leverage other larger scale partners as they, who might have larger discounts, right? That's why in Confluent Cloud we use certain metric solutions or something like that. So I'll get into that in a little bit. Okay, so if we just look at these 2 theoretical workloads that we came up with, this is how the prices break down. And we'll go through how we got these numbers in a little bit. But you can see that there is, it's not exponential, but it's close to it as the workload is increasing. It's not sublinear, whatever the opposite of that is. And you can see it growing, but as the key here is you will see very closely that some of these costs are growing faster than others. And that's really important to take into consideration. Okay, coming up with compute is very easy. This is the easy one, and more often than not when I'm working with customers, this is pretty much what they show me. They show me compute, and that's what their Kafka costs are derived off of. This is what they're reporting to their management. And it's a really simple calculation, right? It's the number of nodes in your cluster, take the actual VM size, the hourly rate. Anyone know offhand how many hours are in a month? No, it's 730 and a couple decimals. Anyway, so you multiply by 730, and that's how you get the number. So that's how you get your monthly cost. So in this case, we're running some single XL machines, 6 nodes. In our larger case, we're running 15 nodes, 3 quorum nodes sitting outside of it. And this scales pretty linearly across on the compute side. This is easy. Everyone knows how to do this. And it's what I see more often than not when someone's considering what their Kafka costs are. The only thing to consider when thinking about if you have a compute-bound or an IO-bound workload is to be very cognizant of how over-provisioned you might be. It's a question that you have to answer. Like, okay, the cluster is going to need to do X. We're provisioned to do we're provisioned to do X, but the current workload is below that. So just kind of thinking critically about how over-provisioned you are at any point in time is important. And this can really change the compute costs of the cluster. And we'll get back to how to fix this in a little bit. All right, the next one's storage. This is not really thought about that much when it comes to Kafka, but this is an exciting area, both in the what we're doing at Confluent, but also in the open source. I know tomorrow you're going to hear a lot about KIP 405, which is tiered storage going into Apache Kafka. But the way that we measure this is pretty simple. We have those 2 workloads, our 20 megabyte and 100 megabyte. We have a replication factor. We have how long you're retaining the data, and you just multiply across times the actual gigabytes, the rate, which is gigabytes per month rate, and that's how you get your monthly cost. So pretty simple so far. Does anyone see anything that's missing in this? I hinted at it earlier. We'll get to networking in a second. I'm building up to that. Anything specifically to storage that we think is missing? Yeah. So the IOPS that's the second thing that's missing. The first one is the tiered storage costs, right? So tiered storage is going to be available in Apache Kafka very soon. The way to think about it is you have to divide your EBS costs, which is something called the local hot set. So the local hot set is where your EBS costs are going to go. And then you're going to have the retention period minus the local hot set is what's going to be your S3 costs. So it's just kind of a nuance that you have to think through as you go through this calculation. If you're using open source Apache Kafka and you're kind of tuning your hot set. So let's say you had 7 days retention, you have 1 day of retention actually sitting in EBS or a local volume. You'll have 6 days of retention sitting in the local brokers. Note that the replication factor goes away because you're relying on S3's durability. Okay, anything else? The next one is IOPS, so good call. So you have to consider, how many provisioned IOPS are in the cluster as well. Don't forget about this. As you tune your clusters, you have to be thinking about how many IOPS can I include, especially for IO-bound clusters. Provision throughput is very, very important. The pricing on it is a little wonky, so just you have to build some type of tiering mechanism. But we found a lot of benefit thinking about this one. Okay, this is the big one. It's networking. This is Jack Van Lightly's cartoon. He does these. I think they're brilliant. But we've talked about all these costs. We've talked about compute. We've talked about storage. The really big one over there is cross-AZ charges, and that's what we're mostly going to talk about for the rest of the chat. I found this meme. I think this demonstrates exactly kind of how to think about networking costs in EBS. Like there's free egress, and then there's a bunch of assassins sitting behind free egress. But yeah, this is a big problem, like because the world makes memes like this. Okay, so let's kind of go through how to figure out your networking costs. Like, and this is a really big topic. Like, you'd be surprised how many folks I talk to who will say something to the effect of either, I didn't know Kafka had networking costs. Yeah. And then the second one is, there's no way I can figure out my Kafka networking costs. It's all just built into my EC2. How am I supposed to like pull apart those costs from my EC2 bill? So this will be a way to figure out, what you're actually paying. So in this case, you can see that the networking costs as we scale up that workload, it's an exponential growth. So, you only 5x'd, right? But, you pretty much 5x'd and a little bit more on your networking costs. As you break down, like as tiered storage enters the picture of your networking costs or your total costs of Kafka, networking just dominates the cost equation. So as tiered storage goes in, it used to be very kind of storage costs were a big deal, but tiered storage has made pretty easy work of that. But networking is the big one, and it's all thanks to this guy. It's all these kind of little penny charges that AWS is going to get you on. These are the data transfer between local zone availability within the same AWS region in and out. And these just show up as EC2 data transfer charges. They will show up as just a line item, a single line item. It's not like it's broken out by Kafka. So you have to think about, okay, how do I figure out what percentage of my networking costs are coming from Kafka? This is how to do it. Okay, we're going to break this down into produce, replication, and consumption. Okay, and then we're going to do some really simple math, and you'll understand how to do it. The first time I went through this, it wasn't super intuitive, but by the end of this, I promise you'll be able to kind of run through this math. Fifth grade math, sixth grade math is what we're going to use. Okay, I had to relearn. All right, so we're going to produce some data. We're going to make the assumption that amongst all of these producers across these three availability zones, right? This is one region, availability zones A, B, and C. We're going to have producers spread evenly amongst all of them. We're going to make the assumption that this is a really well-balanced cluster, that you have leaders on each one of the brokers, and that you're producing an even amount of data throughout each of them. But I'm only going to draw what's happening in the A region, but you can make the assumption that this is happening, zone, but this is also going to be happening in B and C in the same manner. Fair? Okay. So we're going to be producing some data. It's writing to broker 0, broker 2, broker 1. Okay, so how many cents is this costing us? Haven't heard it yet. Almost. 4. So this is 4 cents. So every single time we cross one of these lines, it's going to be a cent on both sides. So in and out. Now, this happens 2/3 of the time, right? Because you can see I drew 3 lines. 2/3 of the lines are actually crossing the crossing availability zones, right? So you can generalize this and say network costs 2/3 times 2 times 1%, or 1 cent. That is just the production traffic. Okay. We're not done. Notice the dots in the end. There's more. Okay, replication. We produce some data. Well, we have an RF of 3. The data needs to be replicated to the 2 other brokers. How much is this going to cost us? 4, that's right. Same thing, all right? 4, every time we cross a line, it's going to go across. Okay, so this is 2/3 times 2 cents, or times 2 times 1 cent plus 2 times 2 times 1. That's how we kind of get. So far, we've done produce, we've done replication, now the consume side. Okay. How much is this going to cost us? It's 4, yeah, but it's 2/3 of the time. So 2/3 of the time, we're going to be paying for the reading of this data because you're reading from the leaders 2/3 of the time, and that requires crossing the availability zones across the multi-zone cluster. That's right. So that's the full math for how you get the cross-AZ charges of a cluster, and you can combine these terms and do 20/3 times 1 cent. So you take some common denominators, and that's what you get. You can add discounts. So let's just say you have a discount on cross-AZ. It's pretty simple. It's 20/3 times 1 cent times 1 minus your discount times your total throughput is how you get the network costs of your cluster. This was kind of fun. I described this to someone who is clearly a math major, and he emailed me this back. So he combined a bunch of terms and made it very simple. So your combined effective network rate is 2C times a bunch of stuff, where C is your cross-AZ charge, which is 1 cent. Then your replication factor, I recommend using 3. And then your consumer fan out, and then we'll talk about follower fetching a little bit, but that's a cool little thing where, you know, it goes to 0. But anyway, that's a very simplified version of it. All right, this is where things get controversial. Okay, so you're gonna have to bear with me. This is where things get, we just moved from the very objective side of how to figure out your Kafka costs to the somewhat subjective side. All right, so these are the operational costs. And I'm gonna make a bunch of assumptions. So not only, you know, the total cost of ownership of a Kafka cluster cannot just be the infrastructure costs. It has to also include the operational costs of your cluster as well. Now, there's 2 deployments. One is kind of an early stage, and then maybe an at-scale stage cluster. And I'll go through a little bit more about how I'm deciding on, you know, what those are. But the assumptions I'm gonna make are around, you know, maybe 2 engineers to run kind of an early stage cluster, maybe 1, an at scale 7, which in my case, I think that's a generous number to like keep an at scale Kafka cluster up and running. I think 7 is pretty generous. I applied some annual salary, and then I added in the fully loaded costs as well. And I think this is important to actually think about what are the actual operational costs going into my cluster, especially if they're running into production, in production, having to debug production, and that actually has income statement impact, and I'm going to go through that in a second. Now, I think 7 is a pretty generous number in a lot of ways. Like, as you kind of, we have this curve that we use with customers all the time. It's their Kafka clusters grow in complexity. So you start off with like a really small use case. Stage 2, you're going to be adding connectors, schema registry, maybe add some monitoring on top of it. I think 1 or 2 engineers can do most of that, but later on, you're going to be adding stream processing. Okay, now I have to learn how to keep stream processing up. Now I have to keep all the teams that are talking to my cluster happy and make sure that they have what they need. I'm upgrading more components over time. I may have to integrate with the data governance suite or think about geo-replication. And then at the last scale, this is what I've seen, like, gosh, you know, 50+ person teams are when they're trying to operate a super at scale multi-tenant service running the Kafka cluster. So I think the operational costs, they're not insignificant, right? I think infrastructure is where you should focus on, but make sure as you're kind of presenting arguments to maybe, you know, your CFO of like what this actually costs to run, you're considering the operational costs as well. Another thing that gets increasingly difficult is to make the uptime more and more. We have a 4.9 SLA. We have SLOs that are much more intense in Confluent Cloud, but it just gets exponentially harder as you kind of add nines. So as your service becomes more popular at your company, this is something to consider. And the cost of downtime is another thing that needs to be considered. It's somewhat subjective. It really depends on your deployment. But you have to think about, okay, if my service is down, how much will it cost me, right? So you can think about, all right, how often is my service down? What is the availability of my service? What SLOs am I going for? What risk am I taking on by adding downtime to my system? So just another variable to take into consideration. And then there's also a lot that goes into just time to value, right? The amount of time that your engineering teams are thinking about security patches or upgrades. Like these are all things that detract from thinking about the data and deriving business value for your enterprise. A lot of what the keynote was about, if you went to it, was about, I think, moving away from the core infrastructure and into the data layer. And that's the only thing that us as the streaming community are that's the next phase of this, is to popularize streaming, to get it to be something that more folks in the enterprise adopt. We have to move away from all the Kafka infrastructure, and we need to go into the data layer. It's really, really important. And I think there are a bunch of things that are holding us back. I mentioned that these operational costs have real impact. This is an income statement. Does anyone know what company this is from, just based off the numbers? I'd be really impressed if anyone gets this. It's not Costco. No, it's Apple. Okay. So this is Apple's income statement, just looking at it. So these are your OpEx expenditures in the R&D line item. This is your cost of revenue. So whenever you have engineering teams that are working on production Kafka clusters, debugging them, keeping them up, all of that, that should not be here. That is not an OpEx. That's a cost of revenue. So there's a bunch of accounting that has to go on here to keep these up. And there's a lot of auditing that has to happen. And there's no real standard around it. Every company treats it quite differently. But I don't know if anyone's had to do that, but there's definitely hours tracking that has to happen in order to do this public reporting. Okay, so I painted a pretty dire picture. No? Okay, so what can we do? All right, I'm not gonna just say like, hey, this is, we're all not gonna save money. The whole point of this was to save money, but now we understand it and we know what we can do about it. Okay, I'm gonna go through each one of these, give some examples. I think these are 7 very, I'm not gonna say easy things, but things that anyone that's operating, especially at scale, should be doing to reduce their Kafka costs. There's a whole lot more in here, and I'm happy to kind of go through some more of them offline, but I wanna go through these 7 in particular. Okay, number 1. Allow consumers to fetch from closest replica. So what does that mean? This means who's running follower fetching in production, out of curiosity? No? Not a single hand. Okay, there's one thing that you can take away from this talk, turn this on. All right, you can save a whole bunch of money. So how does this work? So instead of reading from the leaders where we had to go cross zone, you can read from the nearest replica of that data, right? What does this do? Well, let's go back to our network problem. That eliminates all the orange numbers, right? So this gets rid of a bunch of factors, and I think this goes down to, I think it's 14/3 times your throughput times 1 cent. So you're saving a good amount of money. Turn this on. There are some networking. I will say if you are crossing VPC boundaries or doing anything like private link, this doesn't matter because AWS won't charge you for it anyway. So there are certain scenarios where cross AZ charges are not in there. So read the user's manual. All right, number 2, tiered storage. This is coming to Apache Kafka. So if you're using open source Kafka, this is something that is coming, and if you have no plans on moving to any commercial offering or anything like that, put this on your roadmap. It's going to save you a ton. You'll hear a lot more about this at the keynote tomorrow, so if you're particularly curious about the progress that's happening here, I can tell you that this will be talked about in length tomorrow. Okay, number 3, upgrade clients. Clients add a lot of undue overhead to the compute of clusters, especially when they are not up to date, because you have to deal with things like down conversion on the message format. That's just added compute that's going to sit on the broker, so you're going to have to scale up, and it's why I see clusters that have like 16x brokers on them that are doing like 200 megs a second. It's because there's like tons of wasted connections, I'm seeing a couple nodding heads when I said that, just scaling up because you have to have the compute. So it's really important to upgrade clients to the latest version. Not only do they have the latest security patches, but they also are more efficient and more performant. They're taking advantage of all the latest innovations that are happening in Kafka. A balanced cluster is an efficient cluster. So cluster balancing, the cluster is really only as good as the slowest node. So if you have a workload that has hot partitions that are on a particular machine, that's just going to bog things down. And then you're just going to have to vertically scale or maybe horizontally scale the cluster. But if you don't rebalance the partitions across the overall workload, you're not going to save anything by doing that. So that's another important point. Balance your clusters. If you're using open source, reassign partitions is your friend. Scale up and down your clusters to fit your workload profile. This is pretty hard to do, but it's especially if you have volatile workloads. This is something that getting very good at is important. It's easier said than done, but let's just say you're planning for like a really big event, maybe a sales day. When you're planning your expansion, make sure you're also thinking about how you're going to shrink that cluster in a timely manner. And make sure you're not investing in any patterns that make that a one-way street. Too often I've seen, well, we grew the cluster because we needed it and we haven't shrunk it back down in a year. That's just a lot of wasted compute, and a CPU cycle is it's a terrible thing to waste. I would say use compression if you're not. Compression is really valuable. I've seen lately, this is totally just me talking. This is not, I can't say this is true for every workload, but recently I've seen a lot of great efficiency gains by moving to Z standard. This is totally workload specific, but I did want to call it out that I've seen multiple times in my line of work where this has been a great option for customers to move to. The last one, negotiate your cloud discounts to fit your particular workload profiles. I think we're all looking to save money on cloud costs, but as you think about your negotiations with cloud providers, make sure you're thinking about the specifics of your workload. I was really involved in a lot of our negotiations with the big CSPs that Confluent Cloud runs on top of. And one of the things that we made sure to do is to think about, okay, how is our service going to evolve over the coming years? What services do we need the biggest discounts on? And you can work with the cloud providers to kind of tailor your discounts to more meet the needs. Like I know we don't have a fairly heavy compute bound workload, right? So I'm going to focus more on like networking. And that's something that you can do as you negotiate with the CSPs. Tailor your discounts. We've done a lot of things in addition to this at Confluent and this thing called Cora that we introduced today. There's a paper that goes into a lot of detail. These are other techniques that you can adopt to gain workload efficiency. We've written about it. There are things that you can do to make your clusters more efficient, to increase compute density on the actual cluster itself. This is all documented in a paper that we submitted to VLDB. That's a link that you can go check it out. So I highly recommend that. I have to plug this. It's my job. I'm not trying to be a salesperson right now, But the efficiency gains that we've done in Confluent Cloud, we're so confident that we can save money. You can do this thing called the TCO challenge, and if we can't save you money, we'll give you $100. So it's worth trying out. So I got 14 minutes for Q&A, and this is where the fun part starts. Thank you.